expressions. If we're going to simplify rational expressions, we better know what they are first. Rational expressions are quotients whose numerator and denominator are polynomials. That's all that's going on here. Actually, if you want a quick phrase of what's happening here, I'll write it underneath in red. Fractions with variables. I'm not saying that's a better definition, but that might really help you know what's going on. We're going to be looking at things that are fractions, but in the top or bottom, or both, there might be variables. And as the chapter goes along, they'll get more and more complicated to deal with. So here's a bunch of examples. All of these look like fractions at first glance, but all of them have variables above and below. That's all. That's the definition. How are we going to go about simplifying them? Well, that's a giant question that we got to answer. What can we do to simplify these things? And to do that, I'm going to write something underneath to give you time to copy down. But I just want to write one mental math question that really is going to define what we're up to here. Here it comes. Don't use your calculator. Do this in your head. 432 times 238 divided by 238. And you might think I'm crazy when you first look at it.
Sorry, it's 432.
It's 432, yeah. Because we know something about multiplying and dividing. We know that multiplying and dividing are inverses. And if you do them right after each other, that's the first phrase that's just scary a little bit. If you do them one right after another, if they're consecutive, they're right side by side, that you're going to multiply and divide, then you can just cancel them out. That's what we'll be up to for the next 2 days, is just canceling those things out, but with variables inside. There's some pitfalls. There's some things to worry about here. But mostly, that's what I'm going to be up to, is like, oh, that goes, that goes. Right? The idea is simple. The execution can be difficult. Oh, and because I want to talk about tests today, I will keep it moving, but I have to pause. During chapter 1, I avoided the problem. I just mentioned it, and again, if I go too fast anytime, you just let me know. I'm making the video, but I'm teaching you more importantly. I'm only making the video if somebody's not here and needs to look back at it. Okay, that's not my priority. So don't worry about interrupting the video and me going back. Don't care. Yeah? Restrictions on rational expressions. Oh, get out your brand new highlighters. Who ended up with the highlighters, you say? And I'm going to put that in red. When working with expressions, we must exclude values that give 0 in the denominator. No division by 0. Now, for those of you in class, I'm going to get rid of those highlighters for just a second so you can see it, and I'll put the highlighters back on in a minute. But I encourage you to, and maybe you're like, oh, I'm not really a highlighter person. Maybe this needs a little red star beside it. Maybe that's how you handle it in your notes. Just put a giant star beside it. Mr. Todd was really on about this. This really matters. I'm not saying it's particularly difficult. That's not what I'm implying at all. What I'm saying is this is vital to what we're doing. And the problem, like a lot of stuff in 11U, and we're going to talk about this a lot this semester, is that the whole picture doesn't get revealed yet. So you're like, well, what's the big deal about division by 0? And it's a really big deal that it's going to matter. We're going to have to deal with it in applications all the way along. But for now, it's like division is 0 is out. And to give you an example of why that's true, I have a silly story for you. Okay? Let's say I'm holding a birthday party. And for the birthday party, I get 20 slices of pizza. And 5 people come to the party. This is not supposed to be a difficult question at our level. How many slices will each person get? 4. But how did you do it?
Well, it's just like 20 divided by 5.
It's just 20 divided by 5, okay? So we had to learn a lot about division to get ready for what's about to happen here. Something's going to fall apart here. So 20 divided by 5 is 4. I'm going to write down the 4, but I don't really care about the 4 per se. I'm really talking about the operation of division. 20 divided by 5. Okay, let's say instead I have a party and I get 0 slices of pizza. And 5 people show up. This is not a problem. This is not a difficult question. In fact, you probably thought it was the easiest question that there was when you were learning multiplying and dividing. I know my kids do when I do flashcards with them with multiplying and dividing. They love this flashcard. They still giggle. If it comes up and says 0 divided by 5, they know the answer is 0. They also know that if it's 0 times 5, it's 0. They just think that 0 means 0. The next one is not on any flashcards. You can reach down and buckle up your seatbelt for this. Because 0 is a big problem. Up till now, it hasn't been a problem at all. You're like, if it's 0, the answer is 0. But nobody asks this question. And by nobody, I don't mean like the grade 5 teachers don't ask it. I'm going to prove that you shouldn't be asking this question. Let's say I get 20 slices of pizza. But there's no people at the party. Now how many slices does each person at the party get? Listen to the question again before it rocks your world. If there's 20 slices and 0 people, how many slices does each person at the party get?
0.
There's no people. So let's put it in. It should be 20 divided by 0. Grab your calculator and type in 20 divided by 0 and watch what happens.
It's 20. No, it's 1.
Math error. Your calculator goes, what your calculator is trying to tell you is, you better check again. That didn't happen. That did not happen. You can't do that, right? And it's not a problem with the calculator, and it's not going to take a new Einstein for the 21st century to figure out the answer. Division was about dividing things up, making groups. Well, you can't make groups of 0. That's not a thing. Division isn't designed to work with 0. So here, what we say is this is undefined. You might have seen that word before. And later on in calculus, we're going to learn a lot more about how we deal with it then. What do we deal? We're not going to solve the problem, but how are we going to deal with it when it is 0 there? Okay? I'll give you another little example that I really like. Say I've got $20, and I want to divide it into, I'm going to use the same numbers, into 5 piles. There'd be $4 in each pile. Let's say I have $0 in my wallet, and all the 5 people in my family want money. How much money does each person get if I got no money? That's not complicated at all. They get 0. But if I got $5 and I try to divide it up into 0 piles of 0, it doesn't make any sense. So this is out. Now, if you only sort of get that, we've had a great day. Because division by 0 is a really big situation. And for now, we're just dipping our toe in it. For now, it's, oh, you can't divide by 0. I'll show one last thing to try to help with division by 0 and why we can't do it. Someone says, well, can't we just use algebra? We've been all about algebra. Can't we just solve for what something divided by 0 is? We just say, I'm going to make it x. X is 20 divided by 0, and I'll just solve the equation. Then I'll find out, yeah? I'll be the one, finally, after 4,000 years of mathematics. I'll be the one that works it out. I'm like, okay, let's solve it. If it's divided by 0 over here, when I bring it over, it becomes multiplied by 0. And now your job is to find the number that you multiply by 0 to get 20. What number do you multiply by 0 and end up with answer 20? There's no number that does that. No solution. And no solution coming. No like, oh, what if I take math at university? Graduate work, PhD, learn everything that every mathematician knew all the way along. I say you already do know everything every mathematician knows about this situation. Divide by 0 is out. No dividing by 0. When working with rational expression, we must exclude values that give 0 in the denominator. We are completely not allowed. Do you have any questions about that? It's a deep, scary subject, by the way. But in 11U, let me show you what it actually means to us. We won't have to do much about this. We can look at this and go, yee. And then when I show you what we have to do with it, you'll think it's pretty simple. In the following expressions, state any restrictions on the variables. Here's what our job will be with the division by 0 thing. We look at the denominator, which I'm going to highlight. Oh, I forgot to highlight the other thing, didn't I? I said I was going to go back and highlight it, but you have trouble reading. I use red to mean really important. That's how I use red. You might have your own color coding system if you got the 4 colors that you can use consistently through your classes and go, here's how I code it. Green is ask the teacher. Yellow is make sure I memorize this. Whatever your system is, yeah? But I use red in my class to go, red is like, whoa, that's important. That's just like highlighting in English class. That's not what I mean. It doesn't mean like, hey, yeah? I don't mean difficult. I don't think this will be difficult for us in grade 11. So our job in this one, in the following expressions, state any restrictions on the variables. All you have to do for this is look at the denominator and say, what can x not be? Or it would be divided by 0. What x value are you not allowed to sub into this thing because you'd end up with division by 0? 0, okay? Some of them are really easy. You just look and go, oh, okay. Look at this and go, x can't be equal to 0. The advanced functions people, in a set of instructions to graph, we'll just make a rule. And I'll write it down here in gold. Gold for me is like, hey, even if you're confused, use the gold. The gold tells you exactly what to do for restrictions. It's denominator can't equal 0. That's simple. A nice little memory deal that you can put on your study sheet. I gotta have a study sheet? Well, I marked your test. I think some of you might need a study sheet. I'm not making eye contact with anybody. To believe that I've memorized your marks is insane. Yeah? I know something about what happened, but don't imagine I'm making a point when I look at you. I'm focused here on this. And just teaching the next chapter, that's why I mentioned study sheets. X minus 7. Okay, this is really easy once you get the hang of it. But I'll do the steps as if we don't have the hang of it. We look and go, x minus 7 can't be equal to 0. Can anyone look at that and go, I know what x value we can't use here? Okay. By inspection? Some of you might be able to go, bang. And I hope that with nice factors like that, oh, is that why we factored? So we get nice factors? The answer is yes. That's what's coming. Nicely factored is good, and I chose all ones that are nicely factored. Nicely factored ones like that, you might not need any steps, but I'll show steps, okay? What we really want to say is x minus 7 can't equal 0. And if you haven't seen can't equal used like that before, it works just like regular equals. You can solve that equation, but you're just solving for x values that you're not allowed to use. Then you can bring the 7 over and make it x not equal to 7. I don't expect you to do those steps every time. I expect that probably after you do a few of these, you'll be able to just look and pick them off. Having said that, every once in a while a situation comes along where we might need that step, where if things get a little hairy. I'm not setting you up for a tough question. That's not what I'm doing. I'm just saying I am aware in my brain that there is times in advanced functional calculus where we had to go, hold on, denominator can't equal 0, and then thought that through, okay? So this one, y plus 5 can't be equal to 0, so y can't equal negative 5. Solving a equation where we're saying can't equal is the same as solving one where it is equal. The interpretation of the answer is different. We can't have y equal to negative 5. That is not allowed. This expression doesn't make any sense if y is negative 5. That's out. How is that going to play out? Well, hang on. We're just on day 1. For now, all we have to do, this is our only job on these, is to state what it can't be. That's our only job so far. More to come. If you're impatient, hold on. Don't worry. We'll get to it all, but it's going to take a little time. This one's either really easy or really hard, I don't know. Can you look right at that and go, what x value, when you multiply it by 5, do you get 0? 0, okay? But again, if that doesn't come naturally to you, you got the steps. There's not a lot of steps. I'm not asking you to do a lot of work here. You just go, okay, 5x can't equal 0, so x can't be equal to 0 over 5. I've really extra showed the steps here that you don't really need. Many people will just look at that and go, okay, well, x can't be 0 on that one. Well, that messes people up. They go, well, could x be 0 here? Oh, sorry, I'll go use y. Could y be 0 here? Yeah, look at 0 plus 5. So it's not just the variable can't equal 0. It's denominator can't equal 0. In this case, in part C, y could be 0 because the denominator then would be 0 plus 5. Y can't be negative 5. That's what makes the denominator 0. Okay? This one, x squared, can't be equal to 0. And again, maybe you can look right at that and go, there's only one number out there that when you square it, you get 0, and that's 0. But here's the steps anyways. X can't equal plus or minus square root 0. That means x can't equal 0. Don't get distracted by the plus minus. I'm just being technical there. We'll get to the plus minus thing. Okay? But I'm just making sure I do it right in your notes here. And the same is true for this one. T cubed equals 0. So t can't equal the cube root of 0, which can't equal 0. And maybe I'm confusing you, actually. Maybe you're like, those steps actually make it worse. Couldn't you just look at that and see that t cubed can't be 0? Yes, I totally agree with that. Now, then you say, wait a minute, the title of this lesson was simplifying. We haven't done any simplifying yet. I know. First, the restrictions, then simplifying. Although I do notice here, this one could be simplified. We could make this into t to the negative 2 or 1 over t squared. I'm not really teaching that right there, but I do mention of all of those, that's the only one I see that can actually simplify. More on that in just a second. Do you have any questions? What time do I have here? We're in period 2. I got till 12:15.
10 more minutes. 35.
Put some clock questions on the next test. See how that goes?
Plus 12.
Yes.
Is that first one t cubed can equal?
Good catch. I should have said t cubed can't equal 0. I caught it on the next line, but you're right, I didn't write it there. Great question. Other questions? Taylor, is okay? You're good, yeah. Just stretching, you were. Yeah. Just for the record, I don't bro, I don't my bad. I don't have beef. I speak English, okay? I got this elastic band ready, just in case you want to yawn in the middle of my lesson again, all right?
Sorry,
I'm
stop
really
boring.
good at this.
Stop boring, sir.
I'm not going to miss you. When I shoot it, it's like, you missed his mouth. I know, I hit him in the eye on purpose. Questions here? Actually, I would never do that. I shouldn't even joke about that. I would never fire an elastic at it. What I would do is switch it over to this thing here. See that sends a message, especially if it just misses you, right? Yeah. I don't care if it's recording. I hope his mom or dad hears that. You yawned during his lesson?
I'll just tell her that we were learning about zeros.
That's right. X plus 6 over 7xy. This one, there's two restrictions. Can you see what the restrictions are? X can't be what x value will make that denominator all come out 0. Because if it's 7 times 0, I'll get 0, and then it doesn't matter what y is. But the same is also true for y. So can we have multiple restrictions? Yeah, I'm not setting you up to torture you with a zillion different restrictions. But technically speaking, if there's two variables involved, there could be multiple restrictions. Like this one too. X can't be 0, y can't be 0, z can't be 0. And I'm not showing all the steps now, because I hope you're looking at them now and going, well, I guess I don't need those steps all the time. But if you do need them, they can be very handy, especially right here. This is a dangerous one. Can you just look at it and know what x value you would have to plug into that to get 0 in the denominator? 3.
Plus 3.
Plus 3. If I put 3 in there, 2 times 3 is 6, minus 3 is 3. 3 is fine. 3 works. We're totally allowed to put 3 in there because I won't get 0 in the denominator.
What if it was 0, though?
If x is 0, I get 2 times 0 is 0. Minus 3 is negative 3. That's not 0. The only thing I got to avoid is 2x minus 3 doesn't come out to 0. Good, I'm seeing frowns now. Now we go back to wait, just hold on a second here. I can't do it in my head, and maybe you will get good enough to do it in your head. But when it's sticky like that, you just go, okay, just a minute. It's not a tough equation to solve. I just take the denominator, set it not equal to 0, and then do the solving. And here's the answer I got was positive 3. It looks like it should be positive 3, but it's actually 3/2 is the number that if you put it in there, you'll get 0 in the denominator. Question?
What if you want it to equal 0? Like, do you get to just choose if it does? You don't want it to equal 0. You don't want it to. But what if it does? You don't know what x is.
You're exactly right. That's why I'm stating the restrictions. Essentially, it's a guide to other people. I hand them this rational expression. I say, go ahead and use it. It's a great rational expression. You're going to love it. You can use it to calculate your taxes. You can use it to calculate the diameter of the parts on your Honda car you're building. But, you're warning them, but Don't use x equals 3/2. That will not work. So it's a restriction on the whole situation saying this x value is not allowed.
Why can't it be 0 though?
Because if I put x equals 3/2 into this thing, it'll be division by 0, which we just found out in the previous slide that you didn't copy down, that you can't divide by 0.
Okay.
Any questions? Any other questions?
Yeah,
Do you need more time on that one? We're on slide 4 of 7. I'm saying it for your benefit, because you might be a little drowsy after a liturgy, but I'm also saying it for my benefit to go, am I going to make it? Liturgy day, you're always like, do I have enough time? And to talk about your tests. Aren't you excited?
yes.
All right. Make sure you copy all this down. Simplifying rational expressions. Here's our plan of attack to simplify rational expressions. First, factor. Oh, that's why we had to factor. The only way we're going to know what the restrictions are and what we can cancel is factor first. So actually, I'm going to put a red exclamation mark after that. I'm not going to highlight it. I'm like, hey, factor first. Go through those steps to factor. What steps to factor? Got to factor. Got to factor. You need to know how to factor from here on in. So if you didn't copy down my awesome factoring lesson, and you didn't try that homework, that's number 1 tonight. Switch over and go, I'm going to be a day behind. Mr. Todd says I have to factor. Thursdays is an okay day to be behind because there's only one more lesson, and then you got the weekend to catch up. My kids live in this mode, my 2 university kids. Constantly using the weekends to get caught up on what just happened during their week. Next, state the restrictions. We just learned about that, okay? I hope now we can state restrictions when we need to. Then cancel or divide, and I'll talk about that. I've talked about this on, what day of the week is this? Wednesday. So I talked about this the day before the test on Monday. I talked about factoring. I just talked about restrictions. You might think, no, today's Thursday. Yeah, so 2 days ago, we talked about factoring. Just now I talked about stating restrictions, and we know how to divide. I'm just going to use it here. And then state the final answer. It'll already be there. The final answer will already be there. Here we go. Always state the restrictions before dividing, because you might cancel out a restriction. So from here on in, you're like, they never mentioned this before. I'm like, I know. You just went ahead and did it. From here on in, you start with restrictions. It's the first thing you do. You go, oh, you look at this. And I like going over here for it. I get it out of the way of my algebra. I just go over here and go, right off the bat, x can't equal 0 and y can't equal 0. Whatever I do next, I can't use this. I can't use what I come up with. If x is 0 or y is 0, in this particular case, I cannot use this algebra to get answers. Then what do, you ask? More to the story coming. For our purposes, we just state the restrictions. That's all we're going to do so far. The story does get completed in advanced functions. So don't think that math doesn't know what to do or how to deal with this. We won't teach you to divide by 0, but we will teach you to deal with it and what you're going to do about it. Now, after that, there's no factoring to do here. I use the first example to go, okay, well, no factoring yet, but we'll get to ones with factoring. After that, you're just simplifying. Now, having marked your tests, I think some people are just having trouble breaking the question down. Because I can tell you, when my brain looks at this thing, see if I can get this view thing to work here. What it's called. Charts, next previous page zoom. Browsers, no, that's not the one. Tools, yeah. Revealer, no, spotlight. Circular spotlight, yeah. Let's see if I can get this to work. This is, if you could see inside my brain, and who wanted to mind meld me with me yesterday? If you could see inside my brain what I'm thinking when I see this, I don't see that. I see that. I go -6 over -18. First, I deal with that. So I don't look at the whole thing and let my brain get all muddled and confused. I just go -6 over -18. I'm going to write the answer, and then you argue with it just in case you had it backwards.
It's 3.
It's 1 over 3. 6/18 reduces to the fraction of 1 over 3. I've taken care of that now. Then my focus switches to the x's. And it's x squared over x cubed. Dividing. What operation do we do with the exponents when we're dividing? So I'm subtracting that, so I get x to the negative 1. Yeah? Some of you might do this slightly differently. And then the final one, y cubed over y. Subtract the exponents. 3 minus 1 is 2. That's my basic strategy when we're dividing like that, is I just look at the pieces that can divide and take care of them. What was it called again? I've already forgotten the name of this silly thing. Spotlight. Turn off the spotlight. There is one more step I should do, which is to go, the y squared stays in the numerator, but the x comes to the denominator. Some of you might be really good at this by now and going, okay, well, what's really happening is x squared, x cubed, 2 of the x's are going. There's 1 x left over in the denominator. There, that's our game. Our game tonight is cancel what you can after stating the restrictions. So this algebraic expression is equal to this algebraic expression. Instead of using this, you could use this, as long as x or y aren't equal to 0. And if they are, you shouldn't be using any of it. None of it works. That's awkward at this point. You're like, why didn't anyone mention this? Like, well, there's already a lot going on, so we waited to hear. Nathan, question?
What about the negative 1?
This x to the negative 1, because I moved it to the denominator, became x to the positive 1. Those might not be exactly how you're handling it. You might have been doing this slightly differently. So I bring up the way, I try to be consistent with how I've dealt with it. But many of you, I saw on the test, had many different ways to manage all of this. But do you have questions about that with 2 slides to go? I keep saying that. People in the video are like, why are you on about this? I'm low on time today. Am I? Period 2, 12:50. Oh, I still got half an hour. Dion, question. You don't get lunch till 1:15.
1:55. Actually, sir. Actually, I have lunch in 20 minutes, so
Why?
He's a spare.
yeah.
He thinks he's slow.
I get a 2-hour lunch. So.
Well, thanks for bringing up your own personal situation in the middle of our.
No problem. I just thought like when you looked at me and said you guys don't.
No, you asked when the lunch is. So I said when the lunch is, and then you changed the topic.
And I'm just like, listen. Like,
You did the old switcheroo on me.
Well, 1 plus.
You said, what color is the grass? I said green. I said, and you're like, well, the sky's blue. And I'm like, what? That's not what we're talking about.
10 plus. Wait.
Was there a question out there? Dion, question. Say it again.
What if it has to be 0? If you make it so that it can't be 0,
All I'm saying is, if x or y is 0, don't use this expression. Don't use this expression. You're out of luck. None of these expressions are going to work to get an answer because I can't divide by 0. I won't be able, when I put in my calculator's going to go, I don't know what's going on. You're like, well, what's going to happen? There's going to be a gap in the graph. To give away the grade 12 thing, there's going to be a gap. There's going to be a break in this graph where you're not allowed to go there. Okay? But that's the rest of that story comes. Yeah? Hazel.
So like the y squared over 3x, that's the final like answer?
Yes.
And then you don't have to restate the restrictions?
Yeah, well, technically you should. Technically, if we are really doing therefore statements carefully, down here then you'd say, comma, x can't equal 0, y can't equal 0. But by putting it over here, I'm trying to simplify your life a little bit to go, there's the restriction for the question. But you ask a very good question. Technically, it should be right there. Other questions? Those were good ones. Oh, here we go. How many got? B, C, D, E, F. Just examples, okay? What was the first step in all of this? Factor first. Okay, so 24x cubed plus 6x squared plus 12x. What step of factoring do we do first?
common factor first.
Yeah, you know what? We're putting it up there.
Yeah.
It's going to be back here. Anytime you want, any test or exam of mine, you can look back in the corner and see this hint.
You got highlighter too.
Common factor first. You should have seen today, AP Calculus. They're having an awful time with a particular equation. And they came to me and said, Mr. Todd, what do we do here? I'm like, common factor. And they're like, spooky. What is the common factor up top here?
It looks like it's gonna be 6.
That looks pretty accurate to me.
That looks good to me.
You have
Oh
to
wait, no,
divide. You have to
no,
divide.
you can do more. You can do more. 6x.
Just because it's your birthday.
You could also do 2 if you want.
No.
You can multiply,
Yeah,
make
but-
it easier.
No.
You want to use the biggest factor.
2 doesn't divide into everything that's left there. Incidentally, if you think I've skipped something, I have. I'm trying to catch you. There was something I should have done first. But the factoring's right. The factoring is correct. Now what? So state restrictions. I should have done that first. Right up here, x can't equal 0. I did it in another color. Do it first, or you'll forget.
I thought you factored first.
Oh yeah, I forgot to factor the, yeah. That's wrong in there, isn't it? It's 4x squared. Good, thank you. That's what you two were saying. Yeah, you got the 4 there. Okay, good. Now, what were the steps again? Factor first. Restrictions, factor and restrictions. Then divide what you can. Look, and I must tell you, the homework is rigged up so like things divide all the time. Does that always happen like that? No, but today we're practicing canceling, so a lot of the questions, after you do the factoring, you'll be like, oh, cancel. So you get out your fancy cancel pen. I'm going to use blue, and the 6's cancel, because 6 divided by 6 is 1, so that goes. Then an x cancels, because your x divided by x. And so my simplified expression is 4x squared plus x plus 2. But again, technically speaking, we should state the restriction down there to warn people. Say, don't use this. You can't use this if x is equal to 0. And that's the end of the story for us. We will pick it up in advanced functions and go, yeah, but what are we going to do? How are we going to handle this? There's more to the story coming. But for us, we just go, x can't equal 0. Okay.
There's like a lot of like ifs, like.
Okay.
I still don't get this.
Yeah, get ready. Get ready. I hope I'm answering your question. And I hope it doesn't sound condescending. I hope I'm just giving you the lay of the land here. Up to the end of grade 10 math, it's more of math playground up to that point.
Oh.
You really haven't. Reminds me of the baseball team I'm coaching. All this season we just did drills. They threw the ball, they caught the ball, they hit the ball, ran around the bases, not too much going on. We haven't played an actual game yet. Grade 11 is the first one where you're getting in the game. So if it feels like the story is completely incomplete, you're like, yeah, but what happens if there's guys on first and second? What about that? Yeah, I know. Hang in there. Keep taking the notes, keep copying things down.
Like I did.
Like you do. Do your homework, and the story just gets better and better as we go. Okay? But for now, all we need is this. Yeah?
So you coach a baseball team that doesn't play?
They're starting to be more intelligent about baseball and starting to teach it in practice format instead of game format. You drive kids out of baseball if you're constantly going, no, you're out because you didn't touch this base. You're safe because you left your base early. If you do all that, kids quit baseball nowadays.
Baseball's easy. You just hit the ball.
You're wrong about that.
I played for like 6 years.
You're making my point for me. Again, you're saying things,
I picture.
you're too caught in your own personal experience. You got to see a bigger picture. Yeah. First step of this one.
I say we state the restrictions.
Factor first,
Oh, we have to.
or we won't be able to see the restrictions. So here, factor first. X over, what's the first step of factoring? Common factor. This one has a common factor. And now part of the story comes in. You're like, why do we care about factoring? We care about factoring because it's going to be very difficult to state restrictions if we haven't factored it before. Not many people can look at 2x squared minus 4x and know both x values. But now I can see them. I can see exactly the 2x values that I can't use. X can't be 0, and x can't be 2. If you don't factor it, you won't see all the answers. So I stated restrictions after factoring. Now I can cancel. The only cancellation I see is the x's. It's multiplied and divided by x. So those go, and I'm going to write down something mysterious here. If you don't have a question here, I don't know what's happening. And I'll state the restrictions again. But I hope you have a question. I hope somebody has a question about what I just did there. The x is canceled.
Oh, I have a question. So now there's like it can't equal 2.
Or x can't be 0.
My head's not grasping this idea of, because you don't know what x is.
I know I don't know. It's, again, let me say it again, but listen this time.
Yeah, but
I'm
you
just
can't prove it that it's not 0.
Just listen. Just listen. Don't worry about saying anything else. Don't worry about interrupting. Just listen. What I'm saying here is, if you take 0 or 2 and try and sub it into this thing, you won't be able to get an answer. So this is just a warning to people. I'm not telling people what x to use. I'm saying use any x you want. But if you use 0 or 2, this isn't going to work.
All right. No, I guess.
So it's just a restriction. Yeah. Good. But what's the question? There should be a question here. Why is there a 1 up there? Yeah, that's a great question. It's a great question. What's 5 divided by 5?
1.
What's 10 divided by 10? 1. So there's sort of a 1 laying around here all the time once you divide things out. X over x is 1. Why didn't it happen over here? Well, it could have. 6x over 6x, I could have put a 1 up there, but it wouldn't have changed anything. So once everything goes, you think, oh, it's got to be 0. Not in division. When everything goes in division, 1. Your answer is 1. Question?
Why doesn't that x cancel out the other x?
Oh, because this one's being subtracted. This is multiply and divide. That's that little warning right at the start of the lesson where I went, when it's multiply and divide, and that's the first thing you see is multiply and divide, you can cancel. But you can't cancel with stuff that's being subtracted. Because division and subtraction aren't canceling procedures. It's a good question. It's a better question than you might think. You got to watch out for that. You can only cancel things that are multiplied and divided. Oh, this is just math cruelty. Okay? This is somebody, whoever typed this up was getting you ready for situations where things look messy. Here's what you should do, and this is why you should copy these things down instead of playing on your phone while I'm talking about them. So you have it in your notes, and then you can look back at it when you run into the situation. What you should do with all polynomials from now on is write them like this. Do you see what I did at the top one? Put the x's first. If we're going to look for cancellation, if we're going to look for similarities, they better be written the same way. So now that's written the same way. So now I'm going to common factor the bottom. What's the common factor in the bottom? 2. So now this is 2x minus 3, which starts, maybe not the first time, but we've got to get to the point where when we see that, you're like, oh, 2x minus 3. This is negative 2x plus 3. There's sort of a common factor in the numerator, too. The common factor is negative 1. Now give that a long look. A long look.
I'm looking.
To see if you agree it's correct.
I think
Here's how we check what's correct. What's 2 times 2x?
4x.
What's 2 times negative 3?
6 negative.
6 negative, yeah. So the denominator is correct. Let's look at the numerator. Negative 1 times 2x?
Negative 2x.
Negative 1 times negative 3?
3.
Yeah, it works. Okay, what's the lesson from this?
Wait,
Get
hold
your polynomials
on. Oh,
with the highest power of x first and get it to be positive. Little warning, little trap there. Is the whole test for the next chapter going to have these on them? No, but there'll be one question. It's the difference between getting 95 and 100. It's the difference between getting 80 and 85. It's catching this situation like, oh, get them lined up the same so you can see the cancellation. And look, check this out. Multiply by 2x minus 3, divide by 2x minus 3, and this gets shockingly simple, negative 1/2. After all that, what did I forget to do?
You gotta write when x can't be.
Good. You're going to miss it, and you're going to be so mad. So this is you handing in your test next chapter. You're walking up to my desk, flipping through it, checking restrictions. In fact, when I set this test down next chapter, I'll mention it again, I would write it right at the top of the test. As soon as I put the test down, I write restrictions. And then when you're handing it in, check all the restrictions, because nothing more annoying. to know how to do restrictions and just get hung up on the test and forget to do it, all right? So up here, 4x minus 6 can't equal 0. 4x can't equal 6. X can't equal 6/4. X can't equal 3/2. I didn't do that fast to confuse you. I did that fast to stay on point, to go, what are we talking about here? I will pause for question. So maybe to finally answer Kyle's question, 3 minus 2x equals 4x minus 6 equals negative 1/2, no matter what x value you put in, unless x is 3/2, in which case this you can't use this at all. What are you going to do then? You're going to show up for grade 12 and you're going to find out how to deal with that situation, okay? But this is as far as we go with it. Whew! Do you have questions about the steps I did in blue up here though? Because I did that fast on purpose. I wasn't trying to be confusing. I was trying to go, let's stay on point, which is denominator can't equal to 0. Then I solved the little linear equation there. And now if you didn't copy down that gold I wrote on the first page, denominator can't equal 0, maybe now you want it. Like, every once in a while I need that. Every once in a while I can't look at it and see the answers. How am I doing? 15 minutes for 2 last examples. Is that right? E and F, is that what it was? Is anyone printing these things? Is everyone keeping up now going, I'll go the night before and print them out? And those of you who have iPads, it's there. You could just grab it off the website. Yeah. Ooh, it's in Word though, is it?
If you export it, it's just, even if you just download it, you just go into the Word document and export it as a PDF.
Okay, let me know. Because the calculus people used to yell at me. Because Word used to be better on iPads than PDFs, weirdly. Now it's the opposite way. PDF seems to be better. So just yell at me at the start class. Mr. Ty, you didn't put the PDF up. I'll put the PDF up, and you can just grab it right out on your iPad and write right on it. Yeah. Yeah. There's something about Word, though. It's a little, like PDF works so nice now. Yeah. Last 2. Now, these are totally incorporating the skills you were supposed to practice with factoring. Factor first. Does this numerator have a common factor? No. Is it a difference of squares? Is it 2 terms? No. Is the a value 1? Yes. And if you're like, I don't remember all those steps, I know, go back and watch that video. That video walks through it and says, here, this, then this, then this. It gives you a set of steps. So I'm looking for 2 things that multiply to negative 10, but add to negative 3.
Wait,
5 and negative 5 and 2.
I love the way he said that. He knew it was 5 and 2. And then he just had to work out where do the positive and negatives go. But you can always check. I'm weirdly unsympathetic about people who get wrong answers with factoring. Because you can always check. X squared minus 5x plus 2x is minus 3. You can just FOIL it out and make sure it's right. You don't need any of my methods at all. You can just say, oh, just get it so it FOILs out to what's there. So what multiplies to 15 but adds to 8? Positive 5, positive 3.
what happens to 3? Or well, in the top one. No, okay, what happens to the 8 in the bottom one?
It's
5 plus 3 equals 8, buddy.
Oh, plus and then add and then 2 plus negative. Oh my god.
That was a fun trip you took on us all. Thank you.
No problem.
Okay, factor, then state the restrictions. But lots of times once you factor, it's easy to see the restrictions. One of the reasons why we factor is you can just look at this now and go, oh, x can't equal negative 5 or negative 3. I did it that way for the first time instead of on separate lines. It's an easier way to write it. You can just list off the things it can't be. Does anything cancel this time?
Oh, the 5s.
No. We're not multiplying and dividing by 5. We're subtracting 5 and adding 5.
Oh, so, okay, so no.
No,
It does.
it needs factors that are the same to cancel. Nothing cancels here. And overall, most times, nothing's going to cancel here. But in the homework, most of them are rigged up. So I just showed one that's like, okay, this one doesn't cancel, but apparently this one will. So we go again. And these are the ones. This will drive you nuts. Because if there's one of this type of factoring in the factoring section of the test, you won't get those marks. If there's one in the factor and cancel part of the test, you won't get that one right. And then there's one in the thinking part of the test, you won't get that one right. 3 whole questions because you don't know how to factor a quadratic with a coefficient out front. You've got to nail this down. The other type of factoring might come back to you pretty easily, but you've got to nail this down.
Are there more restrictions on the first one?
Yeah.
No.
No, because it's just the denominator.
Ju-
I thought it was the top.
Good. Do you hear what he said? Just the denominator. At the start, remember my pizza example? You can have 0 divided by something. That's easy. So 0's up here is fine. It's 0's in the denominator not allowed. Great clarification. All right, I'm going to do the first one using, I'm going to do it 2 different ways for both types of people, okay? I'm going to do the first one using use your brain factoring, as Mrs. Malecki calls it. I call it Jedi factoring, and I often make the lightsaber noise as I was doing it. Yeah? I just look at this and go, come on, I can do it. 2y squared is the first term. These first 2 terms have got to be 2y and y. Got to be. I'm already half done. Now, 2 things that multiply to 15. Couple of choices. 5 and 3, 1 and 15. I haven't dealt with the negatives yet. Let me think it up. Let's see. If I put the 5 here, if I put the 5 here and the 3 there, I'm going to get 10 and 3. That's never coming out to -1. If I put the 5 here and the 3 there, oh, that's 5 and 6. Oh, yeah, that's close. Yeah? So I'm going to go 5 here and 3 there. And so I get, that's going to be a positive here, negative there. I understand some of you are like, I don't like that at all. Please don't make me do that. You don't have to do that. I've got decomposition coming in just a second. But if your mental math's pretty good and you're pretty good at foiling, you might just want to play around until you get the answers. It's by far the fastest way. Okay? Decomposition. Here's decomposition. And I'm going to put a title on it. So if my explanation is not good enough, well, you can rewatch my other video. But if you type in factoring by decomposition into your phone there, there'll be 26,000 nerds who have, that might not be an exaggeration, who have made a video on factoring by decomposition. It's not that bad. Here's the steps. You find this magic number, AC, which here is 4 times 3. And then you take the 12, and you look for things that multiply to 12. I'll write the steps here. Multiply to 12, but add to -13 the b value. Then you're just doing what you did up here. Using your brain to go, okay, well, let's see here. What multiplies to 12 but adds -13? Let's see. Multiplies to 12. 4 and 3. Does that add to 13? No. 2 and 6. Does that add to 13? No. 1 and 12. Oh, 1 and 12. 1 and 12. So the numbers I want are -1 and -12.
Oh, whose birthday is it today, Mr. Duff?
Well, if it's okay, if it's a task for me to quickly interrupt.
Do it.
Yes.
I'll write some
Well,
stuff.
I am just impressed with this classroom.
This classroom
This class.
or this semi-working active board?
It's Reese's birthday. You guys all wore #1 dress for her birthday?
Most of us did.
For mom.
Most of us
Very
did.
impressive, you guys, to do that for Reese's birthday. Well, happy birthday.
Good job, Carter.
Want to bookmark you?
Great job, Carter.
Happy birthday.
Do you want us to sing?
I think we should say.
Aiden, this must be hard for you.
Wow, we can at least say what, class? Happy.
Birthday.
Not your happy birthday song?
Oh, yes, factory issues.
So I finished the steps of decomposition while we were doing our birthday stuff. Mysterious. Hello.
Hey, do you have Kyle O'Malley by?
Yes.
Yeah, can you just guys gonna make pixels up?
Gladly. I was worried we weren't going to finish. Now we will.
Good morning, good afternoon, St. John's. Since we were unable to do announcements this morning, we will be doing the announcements right now.
My brain's going
Darrell Club
everywhere right now.
will be meeting tomorrow, Friday, during junior lunch in room 558. This is a very important meeting as we will be learning more about our first big project. All members and those interested in joining are encouraged to attend. Looking forward to seeing you there. Did you enroll in the art trip to Europe this March break? There will be a very important meeting for students going on the art trip next Wednesday, September 27th, at the start of both junior and senior lunches in room 2058.
Copy for now.
With the Egyptian door.
And then when they're done, hopefully I'll have a couple minutes to tie up any gaps for you.
We have some important information to share regarding the trip. Please see Ms. Kowalski or Mrs. Duffy if you have any questions or are not able to attend this meeting. The Brant County Health Unit is looking for student volunteers to assist with their HEROES program. HEROES stands for Health Educators Reaching Other Students. You can earn some community involvement hours, learn new skills, and meet new friends. The program takes place every Tuesday throughout the school year at the Brant County Health Unit. The program starts October 10th, 2023, and runs from 3:30 to 5:30 p.m. For more information, contact Justine Swan at
gonna be on the video, right?
UCHU.org.
Cal coming
or
up?
call
Absolutely.
26208
Gladly.
7685. This information is posted on the Volunteer Opportunities Board outside of Student Services and on Student Services Mondays. Our SJC football teams play against North Park tomorrow, Friday, at the Wayne Gretzky Field. Juniors play at 5 o'clock and seniors at 7 o'clock. $3 for students and $5 for adults. Come cheer on your Eagles. Student calendars are available for pickup in the principal's office before or after school or during lunch. Students going to Costa Rica and Panama City, there will be a short meeting Tuesday at the start of senior lunch in room 1125. SJC STEM Club is starting back up this year. Our first meeting is Thursday, September 28th at lunch. New members are always welcome. Junior lunch is in room 1131 and senior lunch in room 1125. Calling SJC students, are you passionate about promoting diversity, advocating for change, and celebrating the rich tapestry of cultures within our school community? If so, we invite you to join the School Social Justice Club, ACE, which stands for Advocacy, Community, and Empowerment. At ACE, we believe that every voice matters, and together we can create a more inclusive and harmonious school environment. We have been hard at work planning exciting activities and events that allow us to learn from one another, share our cultures, and work towards positive change. If you are eager to share your culture, student body, promote diversity, or be a part of positive change in our school, ACE is the place for you. We welcome students of all backgrounds, experiences, and perspectives. Your unique voice and passion are what make our club thrive. Our first meeting of the school year will be held on Tuesday, September 26th, during junior lunch in room 1053, formerly room 108. Come meet our current members, learn more about our upcoming activities, and see how you can get involved. To RSVP for the meeting, please sign up on the sheet outside of room 1053 or contact Ms. Custodio by Monday, September 26th. Let's work together to make our school a more inclusive, diverse, and equitable place for all. We look forward to welcoming you to ACE.
It's your birthday, you can't say that.
Golf team. AABA golf will be played next week. Golfers also
No, my team's not.
no pay, no fines. Golfers
Brad might want
Good morning, Eagles. Come visit us in the cafeteria and get your favorite fruit, snacks, and drinks. Today's special is taco fries.
one time.
There will be a dance team practice at Thursday in the fine restroom.
But if I beat you 100,
Please be ready by 3:05 because we will be starting right away. See you there.
it's
A reminder that our first Divine Mercy Prayer Group meeting of this year takes place tomorrow at the start of junior and senior lunch at the Rosary Room. All are welcome. If you are unfamiliar with this kind of prayer, we can show you how, and it only takes the first 5 minutes of your lunch. See Chef Andy in room 2028 with any questions. Would you like to be part of this new NTS collection? There will be a brief meeting tomorrow, Friday, September 22nd, with junior and senior lunches in room 1007, the drama room. If you cannot attend this meeting and would like more information, please contact the director at snally0706@gapencsdsb.ca.
It's fair, but
Now please join me for grace. In the name of the Father, the Son, and the Holy Spirit. Lord, let us pause before we eat and think about the ones in need. Those in need of food and shelter and of love, please bless the food and we will eat today, and help those who are hungry. Amen. In the name of the Father, the Son, and the Holy Spirit. Have a great day.
Okay, fairly quickly here at the end. Don't be intimidated by decomposition. By the time you practice it 3 or 4 times, you'll be like, oh, I sort of got this. There is a procedure here to do. Okay? So I use that to factor cancel what I could and state the restrictions. Oftentimes in the homework it cancels. I did mark your test. I'll talk about that off the video. But if you have any questions about decomposition, come see me at lunch and we'll talk about it. Oh yeah, the decomposition is a little magical. But the decomposition is telling you, how do I break this negative 13 up into the two pieces it was after it was FOILed? So it's going one step back in the procedure and saying, okay, so -1 and -12 are the numbers that came out of the FOIL. How does it do that? Well, it doesn't exactly explain how it pulls that off. Oh, up here? I just used my brain. Some people don't like it. I just went, okay, 2y and 2y, because the numerator was 2y squared. And then here I went 15. I went, well, let's try 5 and 3. See, people don't like this, because decomposition's got steps. Use your brain as like, let's just play around here and see what we come up with. You can always use decomposition.